In a very similar fashion, if I just plug 3 in initially, I do get that 0 over 0, which is again is an indeterminate form. I'm going to now factor the top and bottom a bit. So the top becomes x minus 3 times x minus 2. The bottom becomes 3 plus x times 3 minus x. I can rearrange the bottom a little bit and say, well, you know, x plus 3 and 3 plus x are the same thing, so I can replace that. 3 minus x and x minus 3. And the reason why I want x minus 3 is I notice I do have an x minus 3 on top. It would be good if I could get an x minus 3 on the bottom. X minus 3 and 3 minus x are just opposites of each other. I mean, think about it. If I reverse the subtraction, the only thing that happens is I change the sign of the number. You know, 2 minus 3 is negative 1. 3 minus 2 is positive 1. That's all it does. So, you know, I could say that 3 minus x is the same thing as negative 1 times x minus 3. And when I simplify a little bit, I can rewrite this as the limit as x approaches 3 of negative x minus 3 times x minus 2 over x plus 3, x minus 3. Since both the numerator and denominator have a multiplication of x minus 3, I can cancel those out. And once I get a cancellation like that, then typically that is usually the issue that's causing the 0 over 0 to happen. So I'm going to take this new, more simplified, you know, rational expression, and now evaluate the limit as x approaches 3 for this. So I plug 3 in. I get a negative 3 minus 2 over 3 plus 3, which gives me negative 1/6. So that's the final answer. That's the limit as x approaches 3 of x squared minus 5x plus 6 over 9 minus x squared. Anytime that we do a limit of a function and I end up with an indeterminate form of 0 over 0 and through further work get, you know, a numeric answer, this tells us that we have the existence of a whole. So going back to what we talked about for rational functions before, remember we talked about, you know, a vertical asymptote versus a whole, and it was usually based on cancellation. Notice we still had cancellation here. And what goes on is, like, you know, when I take the limit value, it's of that simplified function, which is what we did when we were trying to find the y-coordinate of a whole. So basically, you know, as x approaches 3 for b, and I'm approaching negative 1/6 as a y value, that tells me that that's where the whole is. It's at 3, negative 1/6, just like in part A, it's going to be at negative 2, negative 4. So this is how they relate to each other. You know, getting a 0 over 0 indeterminate form that eventually becomes a numeric value tells me that I have a whole, and I can figure out the coordinates, because the x-coordinate of the whole is going to be, you know, as x is approaching, and what I end up as an answer is going to be the y-coordinate of the whole. So we were kind of doing that concept of a limit even back when we were talking about wholes and things like that.